Hey guys, welcome to today's tutorial. We'll be covering how to apply conditional formatting to a data frame in Pandas, specifically for a supply chain data. Our task is to identify orders with an optimal, standard, and urgent lead times status, and then highlight the worst suppliers in our dataset. We'll be using a random generated, made up supply chain data to apply this example. Let's start in Google Colab. Once that we have set up our libraries, we will only use pandas for this case and import our data, then we are ready to create our function, the function that will actually help us to apply the conditional formatting to our lead times. So let's jump right into it. Okay, we define our threshold style function. This function takes two arguments using x as representing the lower bound and y representing the upper threshold value. So basically, these two thresholds determine the boundaries for our color coding system. Very simple. Inside of this function, we define the style function, which is going to take one argument representing an individual value of each cell in the table. And this is how it's going to work. If the value is less than x, the cell will be colored in green, indicating that we have an optimal lead time. If the value is between x and y, we will color it in yellow for standard lead time. And if the value is above y, we will return it red, indicated that is an urgent order that we need to address and take actions upon it. Okay, great. Now, the next step is to define these thresholds. In this case, we set up to 10 days for a lower bound and 20 days for the upper bound. All right, now we need to do the job, which is actually applying the function that we just created into our data frame. So to do that, we need to access to the styling properties of our data frame using the style and then map method that applies the function to the function that we just created to the data frame. In this case, we access specifically to the lead time column by using subsets because we only want to color the lead time column. And voila, now we have our data frame with our colors in the lead time column, which is handy to spot the critical values that we need to take care of. It's really important to watch this. But of course, we need more, right? Because just watching the colors is not enough. Despite this data frame being small one, only 1000 rows, it is still difficult to say anything just with this visual information. The next step is identify how bad is the situation. So counting the number of urgent lead times orders that we have. To do so, we need to select the lead time column from our data frame and apply a conditional statement that creates a sequence of true and false values. And true if the lead times values is less than the X threshold, and false otherwise for this specific condition. And then we use the sum to add up all these true values, treating them as one to get the total count of the green category values. For the green category, but it's pretty much the same logic for the yellow and for the red, meaning standard and urgent lead times. And then we print these results. So we have 344 orders that urgent that we need to take care of. But we still need to take this further, right? And that is identifying the suppliers that are messing up. Given the hypothesis that is the responsibility of the suppliers and it's not something happening very crazy. So to do so, now we create a new data frame that we are going to filter just urgent lead times and we will call it urgent VF. And then we create a pivot table function from Pandas. In this pivot table, we need to specify the data frame that we are using, in this case, urgent.df, then the value that is the lead time, meaning the column that provides the values of the aggregation in the pivot table. Then the index is the supplier ID that is in our column, meaning the table will be organized by supplier. And then we will use the aggregation function sum, which means that the lead times values of all urgent orders will be summed up for each supplier. This, of course, assuming again that the suppliers with higher numbers are going to be more critical. Of course, we can use other aggregation functions like count or min, but for the purpose of this explanation, we'll use sum. Then we sort the values by the lead time in descending order by indicating ascending as false. And then the last thing that we do is to rename the columns as sum of the lead time that is going to be the result. And we get to see that the supplier number 14 is the one that has the higher lead times. This will give us an indication already of the suppliers where we need to do some research to understand what is happening with their delays and the lead times. That's it for today, guys. Remember, you have all the resources in the description. Don't forget to subscribe for more supply chain analytics content. And let us know the kind of tutorials that you would like to watch, since we are in a very experimental phase and we want to build this with you. It will be more fun if you give us some input. So, bye-bye.